Alright, in this video we're going to talk about dilutions. So the kind of dilutions that you guys are going to be doing in lab are called serial dilutions, not like the cereal that you eat, like cereal like in a series. Because you're going to have your first tube, which will have your soil in it, and then you'll take out of that and make your second tube, and then you'll take out of your second tube to make your third tube, etc. And so you take out of the tube before to make each tube, and that is what makes them serial dilutions or dilutions in a series. Okay, good so far. So the type of dilution that we are always going to be making is called the tenfold dilution. Okay, so what this means is you have tube number 1, which already has some stuff in it. Okay, we are going to be making, in this instance, tube number 2. So, in order to do the tenfold dilution, the first thing that you have to figure out is how much you want to make. You can make any amount that you want. You guys know I like the number 8, right? My clicker channel is 8. So we're going to do an example down here where we're going to make 8 mils. We'll get back to that. So the first thing you decide is how much you want to make. The second thing you decide, because we're doing tenfold dilutions, each tube that we make is going to be 10% as strong as the tube that it came from. So then, what is 10% of the amount to make? So basically, if number 2 is going to be 10% the strength of number 1, then of all of number 2 that we're going to make, 10% of it has to come from number 1. The remaining 90% is going to be the thing that we're dissolving in. Okay? So then, number 3 is how much is remaining 90%. Okay, so let's make in our example, there's one other thing actually I need to tell you guys. Okay, so because we're doing tenfold dilutions, okay, so the undiluted is 1, like there has been no change. It's not more, it's not less, it's just the way that we got it, which is itself, and so for that we use the number 1. So the first time we do a dilution, it's going to be how much less? We're doing tenfold dilutions, so the first dilution is going to be 1/10 as much as the original, but, okay, 1/10 is not that hard to write. The second dilution is 1/100th, the third dilution is 1/1000th, fourth dilution is 1/10,000th. Like, kind of around in here, it can be easy to lose track of your zeros. Like, accidentally write one too many zeros or not enough zeros. And so, what we're going to use instead of all these fractions are negative exponents. Okay. Even if you're not good at exponents, just hang in there. So the exponent tells us how many times we are going to multiply the number by itself. So 10 to the power of 1 is just one number 10. 10 to the power of 2 is 2 tens multiplied together. That's 100. 10 to the power of 3, 3 tens multiplied together. Oopsie. That's 1,000. 10 to the power of 4 is 4 tens multiplied together. That is 10,000. Another thing that you will notice if you have been paying attention or if you have learned about exponents before is when you are doing exponents of the number 10, then this exponent number is going to match the number of zeros in your final number, okay? So 10 to the 1 is one number 10, which has 1 0. 10 to the 2, let me see if I can get a different and more pizzazzy color. Okay, 10 to the 2 is 2 tens multiplied together, which gives us 2 zeros. 10 to the 3, 3 tens multiplied together, 3 zeros. 10 to the 4, 4 tens multiplied together, 4 zeros. Okay, so that's exponents for the number 10. They're pretty straightforward. Okay, so we are having a slight wrinkle in that we don't really want 10,000 times as much. We want 10,000 times less. So this is when we use the negative exponent. Okay. So if we've got 10 to the 1, we know is 10. If we've got 10 to the minus 1, the minus tells us to put that number in the other part of a fraction. And you're like, hold up, there is clearly no fraction here. I think that you might be nuts. No. There is an imaginary fraction. I know, it's your favorite kind of fraction. Okay, so if we've got any number can always be written as a fraction over the number 1. Not like imaginary like the I, like just imaginary like you can't see it, but it's really there. Okay, so 10 to the minus 1 can be thought of as the fraction 10 to the minus 1 over 1. Then the negative exponent tells us that this number goes to the other part of the fraction. Okay, so 10 to the minus 1 is the same as 1 over 10 to the 1. So by flipping the fraction over, we have gotten rid of the negative exponent. Okay, hopefully this is making some sense to you. So 10 to the minus 2 can be thought of actually as the fraction 10 to the minus 2 over 1. And so then that can be rewritten as 10 to the 2. Again, flipping the fraction changes this to a positive. And we already know that 10 to the 2 is 2 10s multiplied together, or a 1 with 2 zeros. And so we can rewrite this as 1/100th. Okay. So when you guys are labeling, when we're talking about dilutions and when you're labeling your plates and whatnot, you're not going to write 1/10th. You're going to write 10 to the minus 1. And then for 1/100th, you'll write 10 to the minus 2, 1/1000th, 10 to the minus 3, 1/10,000th, 10 to the minus 4, etc. So you can do as many dilutions as you want. 1/1,000,000th. 1 million has 6 zeros, so 1/1,000,000th is 10 to the minus 6, etc. So hopefully this part makes sense to you. This is important to know before you can understand what we're fixing to do with the making of the dilutions. Okay, I'm going to set this to the side. You can rewind if you need to watch this part, or, click back, whatever. Just ignore my computer, it's making noises. Okay, so our goal is to make 8 milliliters of 1 times 10 to the minus 4 dilution. Okay, that is going to be what we're working on. So you guys will need to be able to do this in lab on your homework and for the quiz/test. Okay, so in order to get to 1 times 10 to the minus 4, we can't jump straight there. We have to go, because remember, each time we do a dilution, it's only 1/10th. So we can't go straight from here all the way down here. That is not a real thing. We have to go 1/10th, 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 1/10th. So if I ask you to make the minus 4 dilution, I am actually asking you to make a bunch of dilutions. You can't just skip straight to here. Okay, so we are going to start with the undiluted, which is going to be the soil sample that you will collect from your biosquare outside your tree. Okay, so here we have our soil sample is going to be in a pointy tube. It's solid. Ta-da. We are going to call this the undiluted sample. Some people will call this the 10 to the 0 sample, because if you know a little bit more about exponents, you know that 10 to the 0 is 1. And so it's a way to write 1 and still keep our pattern of 10 to the something. So this is the undiluted, the 1, or the 10 to the 0. But in any case, it is the soil. Okay, so just for the sake of more example, we're going to make 8 mils only of the last one, but we'll make different amounts of the ones between. I'll show you what I mean. Okay, so for our 10 to the minus 1, or 1/10th dilution, let's say that we want to make 6 mils. Let's see. Let's say that we want to make 5 mils. We're going to slowly work our way up to 8 mils. Okay, so our total is going to be 5 mils. I'm super excited, and I know you guys will just get this immediately. Okay, so if our total is 5 mils, and we know that this is going to be 1/10 as strong as this, then we're going to move over from here 1/10 of the total volume. So if we're making 5 mils, then we need to move 0.5 mils from the previous tube, okay? So now 10% or 1/10 of our new tube is the previous stuff, and then we're going to add the remainder water, okay? So from over here, our first step is how much to make. So we're making 5 mils. Because every time we're doing 1/10 dilutions, our second step is what is 1/10 or 10% of the amount that we're making. 10%, if you are familiar with like algebra, of is always times. So 10% of 5 mils is 0.5 mils. And then the remaining 90%, do not worry if you can't do that in your head, because like 90% of 5, you can just do 5 mils minus 0.5 mils, which I'm confident you can all do, gives us the remaining 90%, which is 4.5 mils. Okay, so to make this tube, we're going to have to move over 5 mils from the undiluted, and then we're going to add 4.5 mils of water. Then we're going to mix it up really good. Okay, so that's how we get our first 1/10 dilution. Hopefully, you guys are good so far. Okay, so to make our next tube, remember each of our tubes is 1/10 of the one above it. So since we've successfully done this, our next dilution has to be from the 1/10 to the 1/100th. Okay, but again, we're going to use the shortcut exponent. So this is 10 to the minus 2. I'm going to go ahead and write it down here, 1/100th. Okay, so for this one, we want to make 6 mils, just to make things more exciting. Okay, so we want to make 6 mils. So our first question is going to be, how much do we want to make? Let's see if I can scooch this. How much do we want to make? 6 mils. What is 10% of 6 mils? No problem. That is very obviously 0.6 mils. So we're going to move over 0.6 mils from the previous tube. And then how much is the remaining 90% that we're going to make water? Well, it's 6 minus 0.6, which is 5.4 mils of water. Okay, hopefully you guys are getting the hang of this. So we've run into kind of a wrinkle, and that is, how in the world are we going to measure 0.6 milliliters? Well, this is why we have the micropipetters. So 1 milliliter equals 1,000 microliters. So 0.6 milliliters equals 600 microliters. And so if you remember the pipetters, in order to measure 600 microliters, you will need to use which one? You will need to use the 100 to 1,000. And it is going to look like red 0, black 6, black 0. Because you'll remember, in the 100 to 1,000, this is the thousands place. This is then going to be the hundreds place. And this is the tens place. So that's why we have the 100 to 1,000, is because 1 mil equals 1,000 microliters. So we're going to make 6 mils total, 10% of 0.6. Remember, every time we do 10% dilutions, 10% of 6 is 0.6. 0.6 mils is 600 microliters, which we will measure using the 100 to 1,000 microliter pipette. We will set the display to be 060. For the 5.4 mils, you're going to have to do 5 times 1, 0, 0, and then have 1 times 0.040. So this will get you the 5,000 liters, that is the 5 mils, and then this will get you the 400 microliters, that is the 0.4 mils. So we need to keep on. Sorry, I feel like I'm dilly-dallying. We'll be faster. All right. So then we're going to make 7 mils of our 10 to the minus 3 dilution. Because remember, we're headed to 10 to the minus 4, and we have to do each 1/10. And so what were our steps? So step 1, I'll write them over here. So step 1 is how much are we going to make? Which in this instance is going to be 7 mils. Step 2 is what is 10% of the amount that we're making. And then step 3 is basically how much is left, and that is going to equal the water. All right, so we're making 7 mils. What is 10% of 7 mils? Is 0.7 mils, which we now know is 700 microliters. So we will move that over. And then the remainder, which is going to be 7 minus 0.7, so 6.3 milliliters, is going to be water. We are finally ready to make our 8 mils. I'm a little bit out of markers. Hang on. We'll use a black one here. All right, so finally we're going to make, I don't actually know if this one's working. Okay. We're going to make 8 mils of our 10 to the minus 4. So our rules in step 1, how much to make? 8 mils. Step 2, what is 10% of 8 mils? No problem. 0.8 mils, which is going to be 800 microliters. So which pipetter will you use for that? 100 to 1,000, and it is going to be red 0, black 8, black 0. Thousands place, hundreds place, tens place. And so then once we've added the 800 microliters of from the 10 to the minus 3 tube, then the rest of this volume here will be the remaining volume. 8 minus 0.8 is 7.2 milliliters of water. So hopefully this gives you guys an idea of how to make dilutions.